Welcome to the first episode of Learn Codea by Making a Game. This is a series to teach complete beginners to Codea how to make a game. This series does require you to know a basic amount of Lua, which is the programming language that Codea uses. But other than that, once you learn that, this series doesn't assume that you know anything about Codea, and it will be a step-by-step guide on how you can learn to make a game with step-by-step processes. In this episode, we'll basically be making the circle move, as you see, using our keyboard. So this series does require you to have a keyboard, but in other series I'll create, it won't really require you to have a keyboard. The first thing we want to do is that we want to open up Codea. So let's go and let's open up Codea. Now that we're in Codea, let's click on the Create New button. So let's click on it. Next, let's name the project to something that is appropriate. For this series, we'll call it Tutorial 1. Now that we've named the project, let's click on Project Template. It should be on default, but what we want to do is we want to change it to modern. So let's click on modern. And the location, we'll just choose Documents. And let's click Create. The first thing we want to do is we want to delete all these lines of code you see by default because we won't be using them. Next that we've done that, we're going to now try and type in some code. The first thing we're going to do is that we're going to set up a scene and we're going to set up the properties of the scene. Basically what a scene is, it is the collection and the area where all the entities will be rendered. And this is the place where we're going to add our camera movement, put all our entities, our players, everything will be in the scene. Now that we've written the scene, let's explain what's happening in the code. The first line of code initializes that scene. We created a default 2D scene, basically having all the properties of a 2D scene. Next thing we did was to set the screen to full screen, basically meaning that when we open the project, it'll be full screen, there'll be no more properties on the side, everything will be full and so we can see the project clearly. The next few lines of code basically set the properties of the scene and all the settings that are required for the scene to be displayed when we run the code. I will be explaining this using a little bit of a diagram and an animation to showcase what happened. As you can see from the diagram, there are 13 cubes going from left to right and 8 cubes going from top to down. The 8 cubes going from top to down represents the offal size. The pixels per unit represents the amount of pixels in each grid cell. The third line of code basically represents the background color. Each time the camera clears its color, it will replace it with this new color, which is purple, which we can just consider the background color. And the fourth line of code basically just tells the gravity to become 0 so that the physics doesn't fall. Let's go back to the chunk of code from before. In the draw function, we basically update the scene by delta time and then we draw it. These are the functions that allow us to basically update our entities and see them on the screen. So if suppose there's a sprite, we can see the sprite, or if there's shape, we can see the shape using the scene draw function. Let's now see what happens when we run the code. As you can see, it's just a regular purple screen, nothing special. So let's go and add something more. The next thing we're going to do is that we're going to add a circle entity to the scene. Let's see the code that we wrote. The first line of code basically creates the circle entity and we name it player. The second line of code basically adds a physics body to the entity and we're going to make it dynamic, meaning that it's able to move. The third line of code basically adds a shape renderer, which we haven't created yet, but this shape renderer will basically be able to render the circle shape of the entity, and it has a player size, which is basically the radius of the circle. The fourth line of code is also a component which we have not created called movement, which will be set to 8, and we'll create those later. As you see, we have these two components which we have not created, so what we're going to do is we're going to create these components. So what we're going to do is click on Do, New Class, and let's type up Shape Renderer. And click Done, and now you have your new class. So what we're going to do is that we're going to change this class to be more appropriate for the scene entity system we're using to create this game. Here's the final result of the class, but before we see how the shape is being drawn, let's analyze how a component works in Codea. The first function of the component class is the created function. This is called at the add function when the entity calls it. The parameter size is actually the 5 you saw inside of the add function before when we were creating the player. Basically, every parameter is called after the name of the add function. So that 5 is meant to be the size, which is in the created function. The next function of the component class is the update. This is basically what updates the entity every frame, but we won't be using it for the shape renderer now. The last function you see is the draw function. This is basically called when you want to draw things to the screen inside of the component. So in the creator function, what we do is we create a variable called self.size, which is going to be equal to the variable size from the parameters of the created function. We change the color of the circle in the draw function by calling style.fill. In the parameters, what we put is the RGB values of the color. Finally, we draw the circle using the ellipse function. The first parameter is the X position. The next parameter is the Y position. The reason why we set them as 0, 0 is because using the scene entity system, the X and Y position would be the offset from the original position, but we don't want an offset, so we keep it as 0, 0. Basically, every entity in a scene has its position, but if we add the X and Y position in the ellipse function, it would just make an offset of that original position. The last parameter of the ellipse function is the size. Basically, it's going to be the diameter of the circle since we set it as that by default. Now that we've made the shape component, let's go to the main file and let's actually remove the movement one because we haven't set this up yet. So let's comment it out, and now let's run the project. And you see that there's a circle there. So now what we're going to do is that we're going to just go back and add the movement of the circle. The next thing we'll be doing is creating the movement component class so that we can have movement on the circle. Okay, let's go and analyze the movement component. So in the creator function, we basically assign self.speed to equal the speed that is in the parameters. If we check out the update function, we see that there's a direction and we assign it to an empty vector. Basically, a vector is a component of an X and Y, which you can use for direction, speed, or anything that requires a 2D plane. Afterwards, we change the direction based on the key that's being pressed. We'll be changing our direction based on the WASD keys, which is commonly used for movement in games. If the D key is being pressed, the X direction will be positive, meaning that it will be going right. And if the A key is being pressed, that means the X direction will be negative, which means we'll be going left. If the W key is being pressed, that means the Y direction will be positive. That means it will be going up. And if the S key is being pressed, that means the Y direction will be negative. That means it will be going down. In the if statement, we check if the direction is 0, meaning that no keys was pressed. If that is so, that means we set the linear velocity of the body, which we set in the main file, to 0, meaning that the ball will not be moving. The linear velocity is basically the amount of units per second the ball will be moving. For this instance, it will be 0 since we set it to 0. The else statement is for cases where the direction does not equal 0, meaning that a key was being pressed. Basically, we set the linear velocity to equal the normalized vector multiplied by the speed we set in the created function. The reason why we use the normalized direction and not just the regular direction is because if we use the regular direction, it will make us kind of go a little bit faster on diagonally. Let's look at this little animation to explain it. Suppose we have a circle and it's moving up and also right at the same time. From each component of the direction, it moves about 1 unit. But if we actually take the length of the whole distance it traveled from the start to finish, we realize it actually moved 1.41 units. This would make it that the ball would seem like it's going faster if it's actually going diagonally. To fix this issue, we basically normalize the vector or the distance it traveled so that it can be consistent and everything can be 1, so we can have a consistent speed. When we normalize a vector, we basically make the length of the vector become 1, which is very great to make it very consistent. Now that we've written the movement component, let's go back to the main file and uncomment this for line of code, the movement one, and let's run the code. And if you use your WASD keys, you see that you'll be able to move your key very consistently. No matter if you press both of them at the same time, everything will be very consistent. That about wraps up this episode. So in the next episode, we'll be talking about the sprite animation, and we'll have a coin and a character instead. And basically, we'll also do some little bit of Z sorting so we can have the characters going in front of each other. So thanks for watching, and please subscribe and have a nice day.